We are the Electric Tongue Jack Redesign Phase 2 Power Electronics Subteam. My name is Maxwell Baker.
I'm Jerrad Smithhart.
I'm Suchyta.
Our team advisor for this project is Trever, Hassell, and we are all affiliated with the Department of Electrical and Computer Engineering at Michigan Technological University.
Our sponsor, Stromberg Carlson, is an aftermarket RV accessory retailer based in Traverse City, Michigan. They sell products like ladders, handrails, and tongue jacks. Stromberg Carlson contracted 3 senior design teams at MTU to redesign their electric tongue jack into one with smart capabilities, such as Bluetooth connectivity, basic fault detection, remote control, and auto leveling.
Our team was responsible for delivering power to the motor from a 12-volt car battery. We are required to actuate the tongue jack under a maximum load of 4,500 pounds, and we will use circuitry to determine motor direction, power an LED light, and activate the magnetic brake. Doing so will generate a lot of heat, so we will have to deal with the thermal capabilities of the board as well. In order to actuate the motor in certain directions, we can do so by applying voltage over different leads of the motor. So, by applying voltage on one polarity of the motor, we can turn the motor in a certain direction. And by switching the polarity of voltage across the motor, we can turn the motor in the other direction.
Some design issues that were addressed during development throughout the year is signal traces and thermal displacement. This helps the board comprehend what's going on throughout the entirety of the circuit. The component selection and placement. The selection allows us to select specific values that are viable for each option. And then the placement determines how close or how far it should be from the signal or desired component it's operating with. Manufacturing capability. Most of our manufacturing was done in-house, which our success rate to board was about 50%, where in actual manufacturing, you would rather have that number a little bit higher, towards 100%.
This is the latest tested prototype of our board. We designed the board in Autodesk Eagle. This board has the gate driving as well as the brake and light circuits, and it works in conjunction with another board designed by the microcontroller team, where we send power to it and in turn receive the enable and activation signals.
In this demonstration, you can see that as the jack is going up and down, on the right, we loaded the trailer with a UTV with a snowplow to add some extra weight. Although this isn't exactly 4,500 pounds, this is a loaded trailer, which allows us to get a little bit more of a heat dissipation throughout the circuit. And that's what the guy is doing on the right side of the jack. And then on the left is the oscilloscope measuring the voltage and current that we desired throughout the system. In conclusion, was our solution effective? Yes. It proved functionality both off-load and under-load, along with a successful outcome of $5.80 per 5,000 units. This selection of 5,000 units came from Stromberg Carlson themselves, as that's about the amount of tongue jacks that they produce and sell per year.
Looking forward for our team, we are always looking to cost reduce our board via substituting components and reducing board size. For our final prototype, per continued testing and optimizations, we continue to update the design. This is currently revision 10. Lastly, with our project concluding, all Stromberg Carlson has left to do is package all of our designs into one shippable product. Here is the full listed team, and we would like to give a special thanks to Charles and Robert Brammer as our project sponsors, Trever Hassell as our advisor, and these others.